Here are two examples of inequalities that we're going to solve graphically. Instead of having us work through the Desmos part of it, I've gone ahead and provided the graphs, but let's confirm that these graphs make sense. So first off, our first inequality is 2x plus 5 is greater than or equal to 12. So what I should have graphed is y equals 2x plus 5 on one side and y equals 12 for the other side. When we look at this, obviously our horizontal line does make sense at y equals 12 because the y-axis is labeled or is scaled by 2, so 10, 12, 14, 16, so that looks correct. And our other equation should be a diagonal line going up because it has positive slope, and if you look at the y-intercept, that is at 5, that makes sense. So this is y equals 2x plus 5. To interpret the inequality and solve the inequality, we need to think about what the inequality symbol is telling us. That greater than or equal is telling us that we want the left side of the graph, which is the diagonal line, to be above the right side of the graph, which is the horizontal line. So we want to know, when is the diagonal line above the horizontal line? Well, let's shade that. That would be on this right-hand side. The diagonal line, y equals 2x plus 5, is greater than or above y equals 12 on this side. To find the solutions, we need to think about what the x values are. Now we know the intersection is at 3.5, so that's kind of the first place, and then we would have values all the way out through here. We're just basically shading our x-axis all the way out to the right. So again, our intersection is our boundary for our solution set. So our solution set would start at 3.5, and because it's going out to the right, it's going out to infinity. Always use parentheses with infinity. Because we have an equals in the original inequality, we can be equal to that intersection value. So our solution set is 3.5 to infinity, including 3.5. We could easily check that by plugging a value in right on the edge. So say 4. If we wanted to check that by putting a 4 in, 2 times 4 plus 5, is that greater or equal to 12? Well, 8 plus 5 is 13. That sure is greater than or equal to 12. If instead you wanted to look at putting, say, what would be another value that would not necessarily give us the correct value, something on this side would be something like 3. If I put 3 in, 2 times 3 plus 5 would be 6 plus 5, or 11, and 11 is not greater than or equal to 12. So we were able to check it correctly for both sides of the boundary. So this looks like a pretty good result. Our next example is 4 minus 3x is greater than 2x minus 12. So let's consider this. This time we don't have a horizontal line. We've got two diagonal lines. We've got y equals 4 minus 3x. Now that is a line with a slope that's negative, so it's got to be the line that's going down. So that has to be the red line here, y equals 4 minus 3x. Double check the intercept. That makes sense, an intercept of 4 right there. Our other side, y equals 2x minus 12. If we look at the blue line, this does have a y-intercept of negative 12, and it has a positive slope. This makes sense to be y equals 2x minus 12. So again, look at the inequality symbol. We want to know, when is the line that's going down greater than or above the line that's going up? So where is the red line higher than the blue line? Okay, so if we highlight that, that's going to be in this region right here. So looking at the x values that are shaded here, we've got x values shaded down to the x-axis all the way out to the left. So we're going out to negative infinity, and where we stop is at the intersection value of 3.2. So we're going from negative infinity to 3.2, and if we look closely at the inequality symbol, there is no equal, so I'm not going to include the intersection, I'm going to exclude it with a parentheses. So our solution set I'm going to abbreviate here because I'm running out of room, would be negative infinity to 3.2. Once again, you could check and make sure that makes sense by plugging in a value on either side. So I'll just do 3, which should be in my solution set. 4 minus 3 times 3 is greater than 2 times 3 minus 12. Sneak that in there. 4 minus 9, is that greater than 6 minus 12? Well, is negative 5 greater than negative 6? Yes, it is. Now, be careful with your negatives. The way to think about negatives in terms of greater than or less than, I like, is to do money. So would you rather owe $5 or owe negative $6? You'd rather owe $5, be less in debt. So the negative 5 is greater than negative 6. So that checks as a solution to this inequality.